If you look in the textbook and you look at intermediate value theorem, there's going to be another way that they word it this way or something like this, but they also word it, and I can never quite remember how they word it, but maybe we should look in there and see. It says something like, if it's continuous on AB, then for some C value in the middle there, for any C value in the middle, there's some f of C that's between those two. Like it takes on every single value in there. Do you happen to have the page? I think you're saying this, if it goes way up above and then back down, it still hits all the values in here, right? There's some value in there. It's saying, I think this is how they say it. They say, if it's continuous, then there's some C value. It's really weird. You want to read it? I'm gonna end up writing it wrong.
A function y f of x that is continuous on closed interval a b takes on every value between f of a and f of b. In other words, if yo is between f of a and f of b, then yo equals f of c for some c in a b.
Sounds good, eh? Well, you had no problem with that? They're saying that if you pick some random y value, I mean, they're saying the same thing a different way, but they're saying if you pick some random y value and call it y0, there has to be a c value in there where y0 equals the function value. Like there has to be some function value or there has to be some c value where the function of that c value is that particular y value. Pick any height here, there has to be some x value in there where the function hits that. I know when you read it like that, it kind of makes no sense, but it does make sense. It's saying the same thing a different way. The diagram helps. It's geometrically pretty obvious what the thing is saying. Can we? We're gonna use it to do this. This is just something that some people get troubled by things like this because they want to know, well, just show me how to do this. This is not something to do, but it's a concept to learn, right? That you can apply. You could apply it here. Is any real number exactly 1 less than its cube? So what we want to know is if x is this number, right? If we're using x for that number, what we want to know is x cubed minus x. Is that difference ever 1 here? Well, it's probably has to be, right? If we think about it here, let's think about the differences in these values. Let's think about what 2 cubed is and 2. 2 cubed is 8, and 2 is 2. So the difference is how much? And 1 cubed is 1, and 1 is 1. The difference between that is 0, right? There has to be something in between that makes it true because this is a continuous function. If we were to, if we're graphing these differences, so if you're graphing the differences here, we want to know, is this ever 1? So we're going to graph y equals x cubed minus x. I'm going to put 2 dots on here. I'm not even going to bother putting it on the calculator. I'm going to put 2 dots on here and say it has to be somewhere in between there that it's true. Right? If you put 2 points on here, what did we say? At 1, what was the difference? At 1, the difference is 0. And at 2, the difference is 6, right? If f at 2 is 6 and f of 1 is 0, it has to hit this because we know this is a continuous function. Since this is continuous, all polynomials are continuous. Okay, since this is continuous on these square brackets, remember the interval notation here on 1, 2, on that interval? Okay, then there must be, like they said it, there must be some c value where, we're calling this f of x, I guess, where f of c equals 1. I know you can solve. You can go to your calculator and just solve what it is, right? Look, put in y equals 1 and find that value. I know you can do this. However this function goes, whether it goes down here like that, or whether it goes straight up like this, or whatever, it has to hit that. It has to hit this value right here at some point. Okay, it has to hit 1 at some point since it's continuous. Of course, you can go on your calculator and just plug in y equals x cubed minus x, put in y2 equals 1, and find the intersection. I won't bore you with those details. Any questions about continuity?